Alors, vous avez take. Sorry. See, I wasn't even recording. I just started recording now. Okay, I've mentioned that probability, there's a classical, empirical, and subjective probability. That classical probability is sample spaces, right? Spaces. Empirical probability makes use of frequency distribution, while subjective probability uses educated guess, right? So I was trying to cite an example of frequency distribution problem, where assuming the class of, I think there are 66 in all, right? I'm assuming the class of 66 pupils. And this is the test result over 40. One person had 0, 18 people had, no, how do I say, no. What is this one? 0, 1. Frequency, okay, this is out over 10, right? So one person had 0, 18 people had 2 over 10, 15 people had 3 over 10, and 32 people had 7 over 10. Let's take this as an example. And you have to find the probability that a pupil selected at random scored 7 out of 10. That is supposed to be 32 out of 66. So this is an example of empirical probability, right? So there's also for sample space. So we're going to see a number of examples, right? Now, there's also another thing we need to know, apart from the types of probability. Okay, we also need to know that if an event probability ranges from 0 to 1, this you're 100% sure that such event will never occur. And here you're 100% sure that such event will occur. So in between 0 and 1, you have maybe 0.32, 0.89, 0.5. This means 50% sure, right? So probability ranges between from 0 to 1. Okay. If an event cannot occur, we know it's 0. Another thing too is that the sum of probabilities in a sample, within a sample space of all events in a sample space is 1. For instance, let's assume that you pick a card, or let's take dice. It has 6 faces. 1, 2, 3, 4, 5, 6. Now, what is the probability that when you cast a die, you get a face 1 showing, right? How many ones do you have on the face of the die? There's only 1, right? Hey, lie down. Two. Now 3. So there's only 1 out of how many faces? 6. So this probability is 1 out of 6. This is 1 out of 6. How many threes is 1 out of 6? 4 is also 1 out of 6 faces. 5 is 1 out of 6 faces. 6 is only 1 out of 6 faces. Now, what this probability is saying that the sum is equal to 1. If you add this plus this plus this plus this plus this plus this, it's supposed to give you 1. The same thing with coin. right? A coin has two faces. It's either the head or the tail. If the probability of getting a head is 0.5, the probability of getting a head, a tail, is also 0.5. Why? Because when you add 0.5 plus 0.5, it must be equal to 1. Right. Okay. So two events are mutually exclusive. Now let's move on to this particular interesting aspect. Now we're going to see some of these terms. When we say events are mutually exclusive, mutually exclusive, not mutually exclusive, okay, then we also look at independence. Independent and dependent. Complementary events. And we'll look at the counting rules. There's a permutation and combination. Now, when do we say that two events are mutually exclusive? Two events are mutually exclusive if they cannot occur at the same time. They cannot occur at the same time. For instance, if you cast a coin, okay, cannot occur at the same time. Let me write that first. Let's take the coin example. If you cast a coin and also the dice, it's either you're getting a head or a tail. You can never get a head and a tail at the same time, right? If you cast a die, it's either you're getting a 1, 2, 3, 4, 5, or a 6 showing. You can never get all at the same time. So in the case of the coin,
yeah, hello, Sandra. So you can continue the teaching.
We are waiting for him.
Hey, boss, please put off the radio.
Is everything all right?
Has the meeting ended?
Yes.
What? You want to continue your baby-ness?
Okay. Then
Yes.
tomorrow.
Okay.
You okay?
Thank you very much. Bye-bye.
Colleagues, I will say let's devise some means and see how best to help ourselves. This is very serious.
Peter. Mr.
What's wrong with
Peter.
his line?
I'm sure the network.
Oh, but if he knows he's going to like do this with us, he should find a better a place that he can get a better network, because this we have other things doing. We are just online and he's not here.
That's right, Peter.
It's late. You're supposed to go and be with your partners. It's late.
After paying 19K, you want to go and sleep with your partner?
Colleagues, let's be, excuse me for my words, let's be very serious and see how we going to solve this problem. Because it's a very nice, no, the way he started, at least, I mean, to help all of us. So let's devise some means and see how best.
I don't think we are the one to solve any problem here. Since you know you are going to teach us something and you don't have, because he's billing us on it, you get it. So if he need us to pay everything left, we'll pay. Then you should give us good quality teaching.
Yes,
there was one suggestion.
Let me come in over there. The other time he made a point that his network is no good, so you have to upgrade the network. So we have to pay something. So I think
we don't mind paying, but when the way the teaching started, it doesn't encourage some of us to even want to continue, like pay the remaining money left. You get it?
Yeah.
So that's the thing. If some days you tell you should meet, you come on, you be on the waiting thing for almost like 10 minutes before you come, and the network is going on and off. You want to pay the remaining money? No.
You see,
if he can promise us that if we pay the money, he's going to give us quality teachings, fine. We don't care about paying. The money is nothing, but the value for the money, I'm not seeing it. I'm not getting it.
Madam, I'm coming on.
Okay.
For our help, let us solve this issue amicably. If you need it, let's pay by close of this month. Let's pay the money to him so that we talk to him by close of this month. Everybody is going to pay. Then we pay to him. Then you find a proper place for us.
No, I'm not sure it's the paying you. It's not the paying. At least we've done our best. But the question is for him to position himself very well, so that at least all of it. You should just look for an area where he can get.
That's the thing. Yeah.
Hello, I think the one bringing the suggestion that we should pay the remainder of the money. I don't know whether he has done some law, little bit about law. I thought we were just taught some law issue.
Because if
we
you forfeit
and the other party didn't forfeit his portion.
I know.
Why should you commit yourself to pay the remaining ones while the thing is not being forfeited?
I know. We shouldn't bring law in. We shouldn't bring law in.
Charles, you spoke.
But we are just giving possibility. We are humans. Fine. We've paid some. I know everyone on the page has paid something. But if you are going to take money from someone, you go in with your details and everything to ask the person for money. Fine, you asked us to pay. We pay something small. Get to a place that there's good network. When we see that, oh, this guy is putting in effort. Now he's teaching us, everything is going on. Well, why won't we pay the remaining money? But now you put it on, the thing goes off, goes on. It's like he too is not making I was thinking he has a battery issue with his laptop. Then he can borrow for teaching. Then we know that, oh, the guy is trying, let us pay. But if you are not seeing any quite improvement, then you pay. It's the money that we can pay. It's not, but
okay, I think he's back. So let's listen to him.
Sorry.
Let's put it before him and solve this thing once and for all.
Oh, everything that we spoke has been recorded. So later you will play it. Don't worry.
Sorry. Hello.
Hi, you were missing in action.
Hey, I was struggling to connect back.
We are really angry with you. The way the class is going, we are getting tired already.
I understand. It went
The
off.
the on and off is serious. It's sometimes put us off. Like,
true.
because we want to finish with this, get some hours to learn other things they taught us yesterday, so that we can get some sleep for tomorrow.
Mr. Bashu, can you position yourself somewhere so that not particularly in the house, or so that at least you get network and we'll move on. It's just about a minute to go. Or...
Yeah, it's true.
Yes.
Okay. Then we also see if we are confident that you will not be going on and off, I don't know, then the others will also follow. As for payment, we'll do that because it's a contract. So the both parties. Thank you very much.
Okay, we'll think about what to do from here. The other one is, let me see if it's recording. I want to be sure it's recording. Okay, it's recording. So I mentioned that if two events cannot occur at the same time, we said they are mutually exclusive. But it's possible that they can occur at the same time. They are not mutually exclusive. For instance, right? If you toss a coin, and a dice at the same time, there's a possibility that you can get a head and a 6, right? Okay. So let's see for independent. Now, two events are independent if the occurrence of the first event does not change the probability of the second event occurring. Now, if the outcome of one...
Mr. Fortune.
Yes, please.
David.
Yes, sir.
Mr. Fortune, you are teaching us probability.
Yes.
And it has some wings, classical, subjective. I will advise that if it's classical, which is sample space, take sample space, let's clear that one. You come to this one, then you clear down. But when you do this one, so I say this one, this work, and this. In fact, I'm looking at the board, but I'm confused about what you are doing.
Yes, when we start solving examples, probably you get it. And because I'm also sharing the video with you, that's why I'm doing it that way. When you take your time to watch it. Sorry. Okay. So if we're going to solve questions, right? I can't be that. I'm busy. Sorry. Okay. If it's an event, assuming you have a bag. This is a bag with some, say you have balls in them. Okay, let's say in this bag you have 4, 6, 7. You have 7 balls, and in this 4 of the balls are yellow, 2 are red, and 1 is white. If you're told what is the probability, assuming you select at random, what is the probability of selecting a red? Right? First attempt, if you select a red, it's likely to be 2 out of 7. What if you don't replace and you're asked to do pick for a second time? If you don't replace, it means this is no longer 7, but rather 6. So the probability of picking a red it's likely to be 2 out of what? 6. Have you seen that the second result has been affected by the outcome of the first? So in this case, it means that the second result or the outcome of the second is dependent on the first. So that's what I mean by dependent. So 2 events are dependent if the outcome of the second, right, depends on the first.
Left side now, just neck down.
Okay, but it's independent if the outcome of the second is not affected by the first, right? So how do you sometimes tell if one event is dependent on the other? For instance, in this sample space, you'll be told with replacement and without replacement. So take note of that. Replacement and without replacement. Okay, with contemporary, I'm just rushing through this one because I want us to go straight and solve questions. As we solve the questions, we're coming back to these ones, right? With contemporary, 2 events are said to be contemporary if the sum of the probability, sorry. If the sum of the probability of the 2 events is equal to 1. For instance, assuming the probability that you pick a red ball here is, say, okay, let me just take 2. 1, 2. The probability that something will happen is, say, 1/3. What's the probability that that thing will not happen? Is 1/7. So that 1/3 and 1/7 gives you 1. So with contemporary events, it's such that once you know the probability of one, as long as the events are contemporary, you can find the probability of the other by subtracting the first answer from 1. Hello. Hello.
Yeah. Let's continue.
Okay. Now with the classical probability, we're writing the formula now. So write down the formula. Any of the formula we need as we solve the question, we just come back and pick them. Right? It's the formula. It's the number of outcomes in the sample space E divided by the total number of outcomes in the sample space. Right. And with the second one, we mentioned empirical probability.
What is it?
We have that probability of an event occurring is equal to, remember we said we're using frequency distribution. So frequency for the class we're considering divided by the total frequency. Total frequencies in distribution. So this can be the first one. With respect to the first one, we can write it as the number of E all over number outcome in the sample space. But for this one, because we're referring to frequency, you can just write frequency all over N. Then we can look at the addition rules. Remember, we also mentioned mutually exclusive. If two, so look at addition. So let's say that two events are mutually exclusive. If it's mutually exclusive, you're told that two events are mutually exclusive. What formula do? Addition rule says add the probability of the first and the second. So that is to say, we do probability of A occurring probability of A or B occurring is equal to the probability of A plus the probability of B. That's it. But if the two events are not mutually exclusive, so not mutually exclusive, we'll write the formula like this. Probability of A or B is equal to probability of A plus probability of B minus 2. Because we said that if it's not mutually exclusive, it means it's possible that they can occur at the same time. So minus the probability that they can occur at the same time. So this is N, B. That is for addition rule. Let's look at multiplication rules. Yes. Sorry, don't cry. So for multiplication rule, Okay, sorry, I'm back. For multiplication rule, I just pray this network doesn't go off again. For multiplication rule, remember we mentioned independent. So you see, this is addition rule. With whether it's mutually exclusive or not mutually exclusive, you do addition rule. This is addition. You apply addition rule. But if it's independent or dependent, you apply multiplication rule. Once we start solving questions, we'll see how easy these things are. So for independent, so if the events are independent, you write that the probability of A and B occurring is equal to probability of A times probability of B for independent. But what if they are dependent? Sit down, sit down, sit down. Where do you want to go? Yes. If the two events are dependent, we write the second multiplication rule, which is that probability of A and B is equal. Take note that this is and, but this was or. In probability, or is used to indicate addition, and is used to indicate multiplication. So and the probability of A times probability of B, where B depended on what? A. So that's it. And take note for this condition, for this particular condition, understand you'll be given some of these formulas in the exam. So what is important is understanding how to use them, right? So that's our intention today. So that probability of B, where the outcome of B depends on A, is equal to the probability of A and B all over probability of A. In fact, what we did is just to pick this formula and make probability of A the subject, make the probability of B subject. That's why we indicate conditional. So let's move on to a fresh page or board and do just two more before we pick and solve. What we need to do for this is, I've mentioned complementary already, so that one we just add and subtract. But for permutation, the formula for permutation, say n permutation R is equal to n factorial all over n minus R factorial. Take note, you can also write it as n permutation R. Okay, but if it's combination, it is n combination R is equal to n factorial. Note the difference between the two, n minus R factorial, then we add R factorial. When we say factorial, let's assume we want to find 7 factorial. 7 factorial is the same as 7. Count down 6, 5 times 4 times 3 times 2 times 1. 4 factorial is simply 4, count down, 2 times 1. Doesn't matter, you can start from 1, right? 3 up to 4. It's still the same thing. So once you've written all of this formula, let's pick them one after the other and solve. Question 1. I'm sure mine has opened now so that we can, yes, this is it. So I'm supposed to go to page 243. So this is it. This is the end of chapter 4. So this is a summary of what I just did now. If you check this page, what I just explained now, you find them in this page here. Beginning where? This for the addition rule. And where is that? This 243. Okay, probability and counting rules. Okay, not in the beginning, but that's cool. So let's start. Now, interestingly, the answers are here. Let's look at one. Question 1. Let me expand this one. Okay. When a standard die is rolled, find the probability of getting a 5. So this is straightforward. When a die is rolled, you see when you roll a die, you either have 1, 2, 3, 4, 5, or 6. And what is the probability? What's the probability of getting a 1, a 2, a 3, a 4, a 5? Now, this probability, 1 is you have 1 out of 6 faces, right? So 1 is showing here, probably have 2 here, say 3, right? You turn the other side, you have 4, 5, and 6. So this is 1 out of 6. This is 1 out of 6, 1 out of 6, 1 out of 6, 1 out of 6, only 1 5s and 1 6. So the question is, when a standard die is rolled, find the probability of getting a 5. The probability of getting a 5 is 1/6. So the probability of getting 5 is 1 out of 6, or 1/5 is 1/6 is the same as 0.1/6 is equal to 0.17 or 0.176 or 0.167. That's it. Question B. A number greater than 2. A number greater than 2. What are the numbers greater than 2 from here?
3, 4, 5, 6.
3, 4, 5, 6. So what do you need to do? Remember, we are applying what this thing is this. Are they mutually exclusive or not mutually exclusive?
They are mutually exclusive.
Very good. They cannot, 2 faces cannot occur at the same time. So in that case, what rule do you use? If they are mutually exclusive, what rule do you use?
I think
mutually exclusive, use addition rule.
Addition rule.
Yes, but there are 2 addition rules. One is for mutually exclusive. So you just add. So it means that here, the probability of getting more than that is the probability of getting a number larger than 2 is equal to probability of getting a 3 plus probability of getting a 4 plus probability of getting a 5 plus probability of getting a 6. And each of this is 1/6. So 1/6 plus 1/6 plus 1/6 plus 1/6 is actually the same thing as 4 times 1/6. There are 1/6, there are 4 of them, which is actually 2/3. And 2/3 is the same as 0.667.
667.
Okay, so that's correct. Let's see. You can go back and check. See the answer there. An odd number. So odd number, let's come back here. How many odd numbers do we have? 3 is an odd number, 1 is an odd number, 5 is an odd number. So they're actually for probability of getting
5.
Odd number is the probability of getting a 1 plus probability of getting a 2 plus probability, no, not 2, 3, and probability of getting a 5. So this is equal to 1/6 plus 1/6 plus 1/6. And that's the same as 3 of 1/6, which is equal to half. That is 0.5. And that's the answer there. 0.5. Number 2. Now, when a card is selected from a deck, this is very, very important. When a card is selected from a deck, right, find the probability of getting a club, a face card or a heart, a 6 and a spade, a king, and a red card. So the answers are there, but how? Let's see how we get this answer. Before then, we need to understand, for those who play Spa, I think this question is for them. But otherwise, there's a link I wanted. Let me open a link. I should have opened that separately before. But basically, whilst it opens, right, we're going to see that for cards, how many cards are there in a plain card? There are 52, right? Out of this 52, you have, is it the club? Spade. I'm not very good with the cards, but I know there are 52 of them. And out of 52, 10 each are numbered, right? And then you have face. Okay, it's good. I've opened it here. I saved the link so I can share with you. Yep, so this is what I wanted to share with you. Can you see it very well?
Yeah.
So there are clubs. In fact, all the 52 cards are divided into 4. Clubs, diamonds, hearts, and spades. Clubs, diamond, hearts, spades. And each of them are 13. So they are numbered 1 to 13. So the A is always 1. You have 1, 2, 3, 4, 5, 6, 7, 10 numbered. But the other ones are not numbered. The jack, queen, and king, not numbered. So for clubs, right, look at the shape. That's why I call it clubs. Looking at the shape, right? This shape is a club shape. So we have, how many of them? 13 in all. But out of the 13 in all, we have 3 face cards. These are called face cards because you see the faces of people, whether they are jack, queen, kings, and blah, 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 right? So there are 3. So 3 plus 10 is 13. So you have 13 each. So 13 times 4 is 20, 52, right? Sometimes I can ask you a question about color. Now, all these cards are either red or black. So how many blacks, in that case, how many blacks do you have and how many reds? You have 13 here. All the clubs are black and all the spades are black, but the diamonds and hearts are red. So you have 13, 13, 26, in case they ask you about color, right? 13, 13, 26, red, 13, 13, 26, right? So these are the things you need to take note of. If you ask questions about kings, how many kings do you have? You have one king belonging to club, you have one diamond king, you have one hearts king, and you have one spades king. So how many kings in all? 4 kings, 4 out of 52. If they ask questions about queen, they are 4 out of 52. Jack, they are 4 out of 52, right? So that's how it works. So take note, this is very, very important. I saw it today and I was excited about it. It's a summary. So let's go back to our question. Page 243, 240. I'll send the link to you. I think it's quite easy to remember, to memorize, because I doubt you'll be given this information in the exam. Okay. So let's use, based on that information, let's solve this. 2, a club. And let me tell you, you see, we've solved the question about rolling a dice. Now we're solving a question about a card. If you understand this card, it means you can solve any other question about cards. If you understand this die, it means you can solve any other question about a related question. But sometimes you can combine cards and dice. So we're also going to solve that and see, right? Okay. So selecting a card is what we're solving now. There are a total of 52. A. The first question is, selecting a card. When a card is selected from a deck, find the probability of getting a club, right? How many clubs are there? We've seen it that there are 13 clubs. Clubs, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 out of 52. So probability of getting a club is 13 out of 52. And that is 1 out of 4, is a quarter. B, it's the probability of a face card and hearts. What did we say is a face card? A face card are those cards that have faces, right? Let's see how many cards have faces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So ideally, this should be 12 faces. So the probability of face.
It's not 4 times 4.
No, 3. 3 times 4. Face card and not and or a heart. Now, how many faces? There are 12, right? Out of 52. And how many hearts are there? How many hearts?
Yeah, hearts. You said 13.
So 1, 2, 3, there are 13.
Yeah.
But we're going to notice something about this question. 13 out of 52. But see, have you noticed that in the heart, right? In the heart, we have part of it that are faces, is that not?
Mm-hmm.
How many of them are faces?
4.
Let's see. Let's go to the hearts. How many of these have faces? No, 3.
Okay, yeah, 3.
Yes, 3. So if we add that to it, it means it's like tautology will be repeating. So it's either you make it 12 over 52 plus take the 3 out of this, 10 out of 52, right? Or we're going to take the 3 out of this one, right? So we can make it, take the 3 out of this one. So this will be 9 out of 52 plus 13 out of 52. So let's do that. So 52, 52, 12 plus 10. This is 26. 26 out of 52. Two here.
13.
Okay. 25, 52, 22. Okay. Oh, so this 13 out of 52, 52, 26, right? Okay, let's see this one. 9 and this. 9 and 13 is 22 out of 52. Is that right? Okay, we didn't use this one because we said we're supposed to subtract, so we didn't use this one. Take note. We're either using this. We're not using this one. Remember, we said we're going to subtract, so we're using either 12 over 52 plus 10 over 52, which is 52 and 22. 2 here, 11, 2 there, 26. Or the same thing here, 11, 26. And that's our answer here. 11 out of 26. So this is a combination of a card and a spade. A 6. Okay, no, it's still card because this card has a 6. Let's go back and check. How many 6 are there? A 6. So how many cards are numbered 6? 4. 4 cards. 4 cards are numbered 6. So probability of getting a 6 and a spade is equal to, what's the probability of getting a 6? It's 4 out of 52, but this is and, not or. So times, what's the probability of getting a heart? How many hearts do we have? 13 hearts. So 13 out of 52. 4 here, 1. 4 in this is 13, is that right?
Yeah.
And 13 can cancel 13. So what do we have left?
152.
Can you see that? Let's see if our answer is correct. So we have 1 out of 52. D, correct. A king. How many kings do we have?
4.
4 kings. So probability of a king, there are 4 kings out of 52 cards. Okay, a red card, very good. So what about a red card? Red card, how many cards are red? Remember,
26.
Yes.
26.
So 13, 13. That all diamonds and all hearts are red. So 26. So probability of getting red is 13 plus 13 out of 52, which is 26 out of 52. And that is half.
1 over 2.
Correct. So we've solved this question too. Right. Let's move on to question 3. Or should we just skip some of the questions? Should we skip some of the questions?
What do you think?
Okay, let's solve. No. Okay, good.
But we can't do all 2.
Yes, but let's just continue like that.
One by one.
So question 3. We're told that software selection. The top 10 selling computer software titles last year consisted of 3 for doing taxes. So doing taxes, 3. And 5 antivirus. Five and 2 others.
Yeah,
2. So what's the total? 10, right?
10, yeah.
And the question is, what is the probability that it is not used for doing taxes? Not used for doing taxes. If it's not used for doing taxes, probability of not used for doing taxes. Now, there are 2 ways you can do this one. Find the probability of doing it. 1, use complementary probability. Find the probability of doing taxes and subtracting from 1 minus probability of doing taxes. But what is the probability of doing taxes? How many?
3 over
Taxes.
10.
3 over 10. Therefore, the probability of not doing taxes is equal to 1 minus 3 over 10, and that is 7 out of 10.
Yeah.
Or if you're not doing taxes, it means you're doing antivirus or others.
And others.
So it means you find the probability of doing antivirus or others. And that is equal to, remember addition rule, for mutually exclusive, the 2 cannot happen at the same time. So it's the probability of A plus the probability of O. And that is equal to 5 out of 10 plus 2 out of 10. 5 out of 10, 2 out of 10 is 7. Common denominator, 10. So it's one of these ones. Any of them is correct. Are we following? Oh, we are too fast.
It's okay.
It's too fast.
Oh, I see. Okay.
I think you need to give us the recorded version because the network kept interrupting.
Okay. Then the next is, what's the probability that it is used for taxes or one of the other? What's the probability that it is used for taxes? So for taxes, probability for taxes is 3 out of 10. We said or, so or means what? Addition. Others is 2 out of 10. So we add 3 and 2, common denominator, I just add, divided by 10, and that is 5 out of 10, which is half. So that's it with question 3. Right, question 4. A 6-sided die is printed with the number, you see the numbering is different. It's not 1, 2, 3, 4, 5, 6. It's rather 1, 2, 3, 5, 8, and 13.
Mr. 43.
Yes, please.
Mr. 40, go to number 3, the last part.
Okay.
You say we are right as soon as you finish, you go, everything get missing.
So this is the number, this is the latter part we did. So are you writing?
Yeah.
Okay, I didn't know you're writing.
Yes, yeah, but like I said earlier, we have missed a lot because the network kept breaking. So we need the recorded version.
Okay, that's good. Okay, with this particular question, question 4. So we have 6 dice, and they are numbered 1 to 6, 6 faces. Roll the die once. What's the probability of getting an even number? So let's roll the die once. We have, what are the events? Okay, the events or sample space. One, 2, 3, 5, 8, and 13. 3, 5. And 13. So in all, there are how many? 6. What's the probability of getting an even number? Well, the probability of getting each of this is 1 over 6. Take note. This is 1 over 6. This is also 1 over 6. This is 1 over 6. 1 over 6. 1 over 6. And 13 is 1 over 6. So how many of these ones are, did you say odd or even? Even numbers. Okay. How many of these are even numbers? 2 is an even number. 8 is an even number. So just 2. 2 out of 6, which is 1 out of 3. Right? And 1 out of 3 is 0.333. Roll the dice twice and add the numbers. Roll the dice twice and add the numbers. What's the probability of getting an odd sum of the die? Okay, so when you roll the die twice, let's do this. You're likely to get 1, 2, 3, 5, 8, 13. That is the first one. The second one, we can do it this way. 1, 2, 3, 5, 8, 13. Right? So we do this. And we do that. The probability of, and this question is about one sum, right? So you get the first one and you get another one. You get 1 and you get 2. You get 1 and you get 3. You get 1 and 5. You get 1 and 8. And you get 1 and 13. Or you get 2 and 1, 2 and 2, 2 and 3, 2 and 5, 2 and 8, 2 and 13. Or you get 3, 1, 3, 2, 3, 3, 3, 5, 3, 8, 3, 13. Or you get 5, 1, 5, 2, 5, 3, 5, 4. No, this 5, 5, not 5, 4. 5, 8, 5, 13. 8, 1, 8, 2, 8, 3, 8, 5, 8, 8, 8, 13. Or you get 13, 1, 13, 2, 13 and 3, get 13 and 5, 13 and 8, and then 13 and 13. But the question is asking that we sum, right? Getting an odd sum on the die. So now we're going to add each of them and see which one gives us odd. When we add this, what do we get? 2. We add this, we get 3. Add this, we get 4. Add this, we get 6. Add this, we get 9. Add this, we get 14. Is that right? We add this, you get 3. Add this, you get 4. Add this, you get 5. Add this, you get 7. Add this, you get 10. And add this, you get 15. Right? Add this, you get 4. Add this, you get 5. 3 plus 3, 6, 8, 11, 16. 6, 7, 8, 10, 13, 18, 9, 10, 11, 13, 16, 21, 14, 15, 16, 18, 21, 26. Yes, and the question was an odd sum. So I haven't added them. Which of these sums are odd? So let's find. Okay. Odd, 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 odd. How many odds?
17.
Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I counted 16. Oh, let's count again. 16, right? So 16 out of how many? 36, right? Count all together. 36. 2, 4, 6, 8, 10, 12, 14, 16. So this is the same as 2 here, 8, 2 there, 18, 2 here, 4, 2 here, 9, 4 out of 9. Let's check our answer. 4 out of 9. What is 4 out of 9? That's it. What's your answer? So let's move on to breakfast drink.
So let's copy a little.
Okay. Are you a secretary? Secretaries like copying.
Question, I believe so that will look at them.
Your this thing was dragging, so I didn't know what you said.
Hello?
Yes.
Who are we going to get it quickly? The video, so that we'll study.
Yes, you should.
Thank you.
Welcome. Okay, that's it. Let's move on to question 5 or 4. Which of them? 5. In a recent survey, 18 people preferred milk. So this one, is it classical probability or empirical probability? This is not talking about sample space, is it? Or sample space? Okay.
No, there's no sample space.
Empirical, right? In a recent survey, 18 people preferred milk. Yes, please.
How do you know this is classical and empirical and subjective? These are some of the issues. Though.
Can you see that?
Yeah.
So that's why I started.
Yeah. But from the question,
yes.
How do you know this is classical question, empirical and subjective?
Okay,
so that you'll be applying the formula.
Let's finish taking notes and then we'll see. Now, in a recent survey, 18 people preferred milk.
Okay.
So milk, 18 people. And 29 people preferred coffee. $29 people. 13 people preferred juices. As their primary breakfast drink. Okay, if a person is selected at random, find the probability that the person preferred juice as her or his primary drink. The answer is 13 out of 60. Now let's go and solve ours. Sum this up, I think it should be 60. So what's the probability that a person preferred what? Juice. So the probability juice is 13 out of 60. It's as simple as that. Purchasing sweaters. During a sale at a men's store, 16 white sweaters, 3 red sweaters, 9 blue sweaters, and 7 yellow sweaters were purchased. The customer is selected random, find the probability that he bought a blue. So this one, what do you do for blue is simply how many blues out of the total? So what's the total?
9.
Okay, 9 blue out of a total of what? We're not told, but from here we can see that the total is 35. So there are 16 white sweaters. Question 5, right? No. Question 6. Okay, so question 6, we read that during a sale at a men's shop, 16 white sweaters. So white sweaters. White sweaters, 16. The red three, blue, how many blues? 9. And yellow. 7. That's it. What's the total? 16 plus 9 plus 3 is 13. Sorry, it's 19. 19 plus 9, 28. 28 plus 7, 35. And the question now is, A, find the probability that it's a blue sweater. So probability is equal to 9 out of 35. That's it. B, a yellow or a white sweater. So probability of a yellow or white sweater. Take note, we mentioned that anytime you see all here, it should be addition rule. So yellow is 7 out of 35 plus white
16
white
out of
16 out of 35. Now, because the denominators are the same, if you add 7 to 16, that will be 23. Now, a red or yellow. C, probability of red or yellow is equal to probability of red is 3 out of 35. Probability of blue is 9 out of 35. And probability of yellow is 7 out of 35. See that the denominators are the same. Denominators are the same. So denominators are the same. 35, 35, 35. So I just write one of them. 3 plus 9 is 12 plus 17, 19. So there's 19 out of 35. That's correct. Let's see. For sure. Okay, the other question is about budget rental cars. Now, cheap rentals has nothing but budget cars for rental. The probability that a car has air conditioning is half. And the probability that a car has a CD player is less than half. The probability that the car has both air conditioning and CD player is this. What's the probability that a randomly selected car has neither air conditioning nor a CD player? This, have you seen that? Is this one not dependent or independent? So let's take data. I think this should be dependent. Okay, I read a minute. Hold on a minute. Okay, sorry, I'm back. So cheap rentals has nothing but budget cars for rental. The probability that a car has air conditioning is 0.5. So probability that the car has air conditioning is air conditioning. Let's use that A. We're told is 0.5. And the probability that the car has a CD is 0.87. So probability that the car has CD is 0.37. And the probability that the car has both air conditioning and CD. How do you do that? Probability A and CD is 0.06. What is the probability that a randomly selected car has neither air conditioning nor a CD player? The probability that the car has neither air conditioning nor a CD player is okay. We don't know this one, but the question is not complementary A or C, but it's complementary, so you put that above it. This is what we're asked to find, but we need to know the other to find this. This was actually be 1 minus whatever answer we get for this one. So probability of A or CD. But first, let's find this one. Remember, we've mentioned that for dependent event, this is dependent. For dependent event, probability of A or CD is equal to probability of A plus probability of CD minus probability of A and CD. Remember? So what's probability of A? 0.5 plus probability of CD is 0.37 minus probability of A and CD is 0.06, and this should be equal to 0.5 plus 0.37 minus 0.06. Our answer is 0.81, right? It's 0.81. But the question wasn't the probability of A or CD. It wasn't probability of having air condition or CD, but the probability of having neither air condition or CD. So it means that it's complementary. And we've written the formula already. It's complementary. This is it. So since you're looking for the probability of A or CD complementary about the top, this is equal to 1 minus the answer we had, which is 0.81. So 1 minus 0.81 is 0.19. As simple as
ABC.
Correct. You see, your exam is very cheap. Your exam is very cheap.
We pray so.
Yeah. Okay, question 8. You're rolling 2 dice. I think we've done something similar already. Remember this one? This is what we are still coming to do here. Or whatever we did here. But let's check. We don't know whether it's going to be addition or subtraction or multiplication. Now rolling 2 dice. When 2 dice are rolled, find the probability of getting a sum of 5 or 6. So it's still the same table we're going to use. A sum of 5 or 6. Let's find, when we added them, each one give us 5 or 6. How many 5s do we have? I'm going to use red. 5, this is a sum of 3, sum of 9, sum of 3, sum of 5, 1, sum of 5, 1. That's all. So probability of sum of 5 is they're just 2. But we asked probability of 5 or 6. So let's do for 6. So we've seen that the probability sum of 5 is 2 out of 36, which is 1 out of 18. And the probability of 6, a sum of 6. Before we continue, right, I just want to find out how many of you have someone who is doing the WASI or preparing to write WASI, not deck or anything?
We'll check and let you know.
I see. Okay. How are you going to check? I'm asking because I'm starting this hopefully next week. A website to help those who want to write an deck, beginning with the maths. I'll be doing things like this. I'll pick the questions, maybe WASI 2015, for instance. So if there are 60 questions, I'll start from question 1 to 60, solve them one after the other and explain. And how to, for the objectives, I also do for section B. So how to solve them, how to use a calculator easily to solve questions. Instead of for multiple choice, you can use calculator to solve a lot of the questions without even having to write anything, just be shading. Use a calculator, punch and shade. So we'll be doing that. I'm starting next week.
Okay.
Yep. Okay, so 5 or 6. So how many 6 do we have? 5, there are 2. What about the 6? Okay, there's a 6 here. 1. Any other 6? There's another 6 here. 2. Any other 6? Yes, there's a 6 here. Any other 6? No. For the 6, there are 3 out of 36. So we have 1 out of, okay, before we break them down, let's just use a 2 out of the 36 and the 3 out of the 36, so that we know that we have 5 out of 36. Sounds correct? Okay, our answer is supposed to be, we're told 1/4. Let's see, let's go back and check very well. We did the right thing, but let's be sure we didn't leave out anything. How many 5s when we added? How many 5s did we get? How many 5s? 1. I've seen 1 here. There's 2. Okay, so I've seen 2. Oh, what about the 6? There's 1 6 here. There's another 6 here. There's a 6 here. Not even 1, correct? 3 and 3 is a 6. 2 and 4, no 4. 8, 5, okay. Okay, so I think this is all we have. But they're indicating that the answer is they indicated the answer is 1/4, and its summation is or a sum of 5 or 6. So we're supposed to add. We did the right thing. So we add 2 and this is 5 out of 36. But they are getting 1/4, meaning this is 6 out of 36. So they are getting 6 out of 36 when you add both. But I'm not seeing the other one, unless we didn't add something well. So you can go back and check later on, right? This 4, this 7. So you can check later on to see where if it's from us, but we've done the right thing. Let's see the second one. We're told to the sum greater than 9. Sum greater than 9. Which of these greater than 9? So we have 9 greater than 9. There are 2 ways you can do by either subtraction. notice something here. Greater than 9, I can rule a line here. So you can find this less than 9 and subtract from 1, or just go straight. 1 plus 2, 3, 5, 8, 8 plus 4, 8 plus 5, 13, 14, 15, 16, 17, 18, 19. And so a sum greater than 9. Okay, do you know what we are doing wrong? Hello?
Yeah.
Have you noticed what we are doing wrong?
We are following you.
No. Okay. We're told the die. This question, the die was not, die is supposed to be 1 to 6. 1, 2, 3, 4, 5, 6. But this particular question, we're told, is not a normal die. Are you getting it?
Mm-hmm.
So we're supposed to use the normal die to do this, not this type. Right?
Okay.
Okay, so do that for the normal one. So you have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now let's go straight and do it because all the questions are about additions. Let's just add together. 1 plus 1, 2. 1 plus 2, 3. 1 plus 3, 4. 1 plus 4, 5. 1 plus 5, 6. 1 plus 6, 7. 2 plus 1, 3. Okay, maybe I just between 4, 5, 6, 7. Then I enter here 2 and 2, 4, 5, 6, 7, 8. 5, 6, 7, 8, 9. 6. I'm doing 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, 12. Okay, so let's go back and answer the other question. When 2 dice are rolled, find the probability of getting a 5, a sum of 5 or a 6. Sum of 5, 1, 2, 3, 4. And a sum of 6. So we add, this is 9 out of 36. 9 to 18, so 1 out of 4. Right? A sum greater than 9. Well, all these ones greater than 9. All of these are greater than 9. How many? 3, 2, 1. Factorial. The sum greater than 9, 3 factorial. 36. You know why I wrote 3 factorial?
No.
Just to confuse us a little. It's simply, I just wanted to know the sum. This is, oh, it's not 3 factorials. I'm rather confusing myself. Sorry, but I wanted to know the sum. 1, 2, 3, 4, 5, 6. Okay, I think it's still correct. 3 factorial is 6.
It's still 6.
But it actually is not factorial. So because we're adding, we're not multiplying. So this is 3. It should be 6 out of 36. That is 1 all over 6. or 1 out of 3? Hope it's correct. Oh, sorry. You know, these ones are not part of the counting. We're not supposed to count this one in white. So it's rather 3. So we have 1 over 6 plus 3 over 36. But when we're adding things like this, let's just maintain the original. So 6 out of 36 for easy adding plus 3 out of 36. And that is 1 out of 9. 1 out of 9. No, 9, 3. No, 12 times 3. So it's 1 out of 12. Did we do it right? No, there's something wrong. This is 9 out of 36. This is 9 out of 36. What is 9 out of 36? 1, 4. So that's it, 1 over 4. 1 over 4. A sum that is divisible by 4. How many of these are divisible by 4? You can divide this by 4, 1. You can divide 4 by 4. 4 divided by 4 is 1. 4 divided, what number will you have to divide? 8 and 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 out of 36. 9 over 36 is 1 over 4. A sum of 14. The highest you have is 12, so there's no 14. So that probability of a sum of 14 equal to 0.
Is a fortune. This particular, I need to take time and teach us again.
Okay, so but watch the video and see.
Because the way we went out before you saw that it was this, we have to cancel. So I think you have to take time and go through. So
and you are started copying already.
No, I'm saying when I'm studying,
you know what I'm saying? You know why I'm saying it? I'm saying that because some people in the exam, some people can copy someone, and just when they say 5 minutes more, the person you're copying from cancels his or her work. And meanwhile, you have copied pages.
You don't go to exam
you
and
also
copy.
cancel?
You don't go to exam and copy. We write what we know.
Okay. Oh, but it happens.
But not us. People. We don't do that.
Okay. So a sum less than 13. Less than 13. All of them are less than 13.
This tableau, you have to do it well again. You have to do it well.
Okay. We'll find time and do it well again. So this one, obviously, our answer should be 1. That is 36 out of 36. All the 36 are less than 1, are less than 13. So just divide 36 by 36 to get 1. And that is what is here. At least we tried to do right, if not initially the network. And surprisingly now it's stable. Okay, so what I want you to do is that you can go through some of these questions. There are many. Go through them and see any of them that is likely to give you problems. So that when we meet, we expect that you indicate, oh, this, I had problem with this, I had problem with that, so that we know how to tackle them.
Mr. Fortune.
Yes, please.
For me, I just joined. I was having problems with the network.
Hey, you too. I'm not the only one.
How soon I get the video so that I'll go through before tomorrow evening.
Okay. So what do you want?
Come again.
I didn't hear you well. The latter part.
asking how soon can I get a video so that I go through?
Okay, I'll try and make it as soon as possible tonight.
So that I'll just go to get of it.
Okay, please, we need cash. We need cash.
Yeah.
To fuel the system.
To buy electricity.
To fuel the system. Right? It's necessary. Okay, so there are a lot of questions here. Look at them, try them and see. So that in our next, so try them, many of them that you think there's a problem we can solve together. But I hope that any other time, there are more here, but this ones, they are just simple ones. There are also questions on permutations as you look later, you see them. Permutation. But in a nutshell, we should move on to discrete probability. Discrete probability is the end of chapter 5. So we can look at these questions. This is the end of chapter 5 questions. So you see that they are very palatable questions. And I think your assignment was even here also. I'm sure you remember something like this in your assignment.
Yeah.
So we'll solve a number of these questions in our next class, but then try and see how many questions you think you're having problem with in the first one. What we did today, I'll be sending you the videos. If only there's no break in the video. Please send something. Yes, boss.
Since you have a problem with network, I suggest that if you have your own time, solve them when you have the network. You only come, you show the video, and you will explain it. It will be simple.
Oh, okay. Let me consider. In the daytime, I'm always very tight.
If the network, you can solve it. The video is there. You only come, you show it while you be explaining, so that we know we have no problem with the network.
Okay, that's good. No problem. Okay. Take care. Good night. And let me see how to share the video.
All right.